So let's get started again. And in the last part, we just finished the first examples in the Lua documentation. So this chapter 1, we just completed that. And so now we will move on to work on the next chapter. All right, let's get going. All right. In the last video, I forgot to turn on music, so not going to miss it this time. So let's move on to chapter 2. So here, now we have some experience developing a game. Let's develop something a little bit more complex. So I will have the design document, think about the feature and ask and other aspect, EDD. Did we get loose drop frames? Nope, we are good. That's some delay. Yeah, seems to be there's some delay with the system. Give me a second. Hello? Okay. So now it seems to be okay. All right, so let's continue. Actually, okay. All right, this usually begins with a design document, GDD, game design document for any major project. In the interest of moving forward quickly, game title, description, control, and sound. And okay, that's fine. Well, I already have some idea, but for the game that I'm going to write, but right now let's just follow the chapter, follow the examples. Start new project. So go to the simulator. Not this, right? Oh, it is here. Can I configure it to reference? That's it. Show project files. Yeah, okay. Open in editor and so on, that's fine. Oh well, okay. It doesn't allow me to set up. Corona project, let me see if it is actually here. Nope, it's not. Oh well, okay. Fine. Oh. Come on. That. Code, game. Okay. what should we call this? StarExplorer. Okay, it's a blank template. Oh wow. Remove. Okay. Close that. Actually, let's add it back. So any configuration that I have over here, well, I haven't figured that out yet. So, and also this configuration is still not working. So, but we'll continue the exercise as is. Right. So StarExplorer this time under the section where you can select a screen size. Oh, let's close. Oh, let's close the whole thing. Right, and then create a new project. The preset is tablet. Okay, and then again set here. Yeah, actually delete the folder that we just created. All right, call it again. Explorer. So this time do a tablet. Okay, set as a tablet preset. Notice the width and height have changed. Correct. So leave other settings empty. Okay. Close. Yeah, it's kind of weird is that it's open the files like this. This is clearly some kind of a bug. But that's okay. Don't care. Oh. Yeah. Lure and the lure formatter is turned on, but the built-in I have is not. Okay, let's turn on for all of them. All right, and just in case reload. All right, in addition to main, there are two important files which you configure. There's a configure and the build settings. Build settings provides real device with detail they need regarding your app. This includes the support orientation for the app, name of icon files, plugin to include, and so on. So open it up. Focus on this, the orientation. Where is it? Oh, here. The orientation. So our start object will only available to play in portrait mode. So the default is portrait, okay. And then it only support portrait. It's do this extra comma. Oh boy. Okay. Let's move on. So go to the config where we specify the content resolution. Okay, that's good. How high resolution device should be handled, etc. And so the content is this, and this scale is letterbox. It is important to understand that this value do not indicate the exact number of pixels, but rather relative unit of content. The content area is scaled to fit any device. Yes, of course. Especially this especially true for Android device, and nowadays it's also applied to iPhone, right? Because iPhone now have different variations, and of course, Android have it. Have all kind of different dimensions, different resolutions on the device. So in order to write code, write sensible code, you have to have a abstracted unit in when you're dealing with the dimension, because if not, you will have so much problem in working on specific version of well, specific kind of devices. So that makes sense. The scale is letterbox. This important setting specify how to handle the content area of screen, which do not match the aspect ratio defined. Okay, defined by the width and height setting. For example, 3:4 in this case. The most common is letterbox and zoom even. Letterbox scales the current area to fill the screen while preserving the same aspect ratio. So meaning if it is 3:4, because we are talking about in a portrait mode, right? So if its scale is like this, it will try to maintain the aspect ratio, meaning the image will be stretched. Scale the content area to fill the screen while preserving the same aspect ratio. The entire content will reside on the screen, but might resell and back, but also it's not scaling. Different note, however, you can still utilize this blank area, so it will maintain the aspect ratio. Is actually really stays that with black bars, but you can still use the extra area by positioning them or extending them outside the content area bounds. Essentially, letterbox is an ideal scale mode if you want to ensure everything in your content area appear within the screen bounds on all devices. Okay. Zoom even scale the content area to fill the screen while preserving the same aspect ratio. Some content may bleed off screen edge with aspect ratio differ from your content aspect ratio. Basically, zoom even is a good option to ensure the entire screen is filled by content area on all devices. So okay, so basically it's these two. So the aspect ratio is always, well, at least for these two configuration, always maintained. It's just either keep it inside in the bound or keep it outside. So min and max situation. For this game, let's use zoom even. Okay, zoom even. All right, and change that. So game foundation. Now that you understand basic settings and configuration, let's see. Yeah, so this is looking good. Right. So now you understand basic setting and configuration. Let's continue with creating the game. Like the Balloon Tap project, this game will use the physics engine. So let's configure that from the beginning. Okay. So, okay, let's start the engine. So local B6 equals to require, okay, require, so it have B6, this is still buggy. B6, okay, and B6 start, no slip. Oh, it's actually also fill in the semicolon, colon, okay. Oh, it's something provided by the extension. Okay, not going to fuss around that. So set gravity 0, 0. So there's no gravity. Okay, after loading, we set the gravity by default. It simulates standard Earth gravity, which cause objects to fall towards the bottom of the screen. To change this, we set it both to 0 because it's outer space. All right. Our game will randomly spawn asteroid outside the screen edges, so we will be implementing random generator further along this project. First, though, we need to set the seed of the pseudo-random, so seeding the random generator. Begins with semi-initializing. Okay, so following addition to our code, we ensure the generator always start with a different seed. Okay, so seeding. So math.random seed and os.time. Okay. Take away all this semicolon. Who provide me this snippets? Is that you? Code snippet. No. That you? No, that is just the formatter. It really should be you. So keyboard snippet completion enabled or snippet. Keywords. Alamo. Agnostic, hover, runtime, signature, enable. Try this guy. Take a look. Okay. Well, it doesn't complete that, but at the same time, it doesn't have those semicolon. And you saw, having a semicolon over here doesn't make sense. So let's use this extension instead. So the first two lines, this is just a comma comment. Okay, when you intend to generate randoms just once, yes, is redundant and unnecessary, yes, of course. So keep in mind that this documentation is for game developer who have really likely very little programming experience, so that's why it's verbose like this. So for us, we can skip and skim ahead. So let's open in the Explorer also. and then copy the file over the image. All right. Okay. All right, we get those two game objects. Okay, it's a sprite. So by the way, who doesn't know it's a sprite, where basically an image with multiple image in there, and you would use offset to just get the one that you want. So that's exactly what this is talking about. Allow you to load multiple image and frame into a single image. Right, is also used for animate sprites. So what it means over there is that over here we have three image, right? At least for this three, this is the asteroids, and because it's in one image, you can do a easy animation by changing the offset. So you saying the asteroid image is the first, these three sections, and then as the keyframe change, you just add increment, and which will change the offset and display a different image. So that's what it is. So let's see, I mostly created using tools such as texture packer. Interesting. Let's take a look. I don't know about that. This. Okay, cool. Some tools that are available. So following your existing code, create a sheet options table as shown below. Or in the config. So go back in. Oh, this is main, right? In the this is actually creating a variable. So let's type it. So configure image sheet, and so local sheet options equals to, let's see how it frames equal object. Okay, well, it format like that, not my fault. When specifying image sheet, you will specify where the image are located within the sheet. For this game, every image is different size, so we must provide for specific property. Oh, this is actually different. So it's not just shifting offset. It actually the X and Y dimension all need to shift. So for specific property, define the bounding box X, Y, and height and width. That's good. So in Lua, it seems like array or objects, it called table is the same thing. So you have here like this, have one big object, or table, and then inside it have that, and these are named properties. So it's kind of like triple with named, and with names, named triples concept similar to something like that. So asteroid 1, X is 0, Y is 0, with 102, and height 85. Let's see. Okay, so yeah, I do the right formatting. So for the rest, I'm just going to copy, format. Okay, so it like this way of formatting. Okay. All right, if you like that, I don't mind. It's a little bit harder for me to read, but you know, not too bad. Well, for one is because this is still using two space. Generate editor fake. Then size, yeah, okay. I'm not going to fight with you. Keep it for 4 space for now. So asteroid, there's a laser. Oh, here. Okay, fitting it in. So to keep the image size small. Makes sense. All right, in order in which you declare each menu is fair. Within the order is very important. You need to specify a number of frames based on order which it was declared and the sheet configuration. Okay. With this table of information, we can now load the image into memory. So graphic, new image sheets, and then that is, I still like single quote more. Save as pinky. I don't need to use extra pinky power. And then put in the sheet base directory. Okay. Don't need that. So sheet options. There you go. Why is still have that semicolon? Okay. So initializing variable in large program is a good idea to declare all variables that are used throughout our near beginning. Yes and no. Yeah, yes and no. Because in programming, if we really want it manageable, we should do some organization. But for now, let's just follow the examples. Once we finish the examples and when we start working on our own project, we will know what to do. So for now, just let's copy this. We keep track the number of lives remain. Okay, the score, did you die? The table of asteroids, your ship. There is some kind of timer. All right, the one that interesting would be this. Will be used for very specific purpose throughout the game. As you recall in the previous chapter, Curry indicate a lure table array. Among other things, tables are used to keep track of similar types of information. Since there will be many asteroids on the screen in this game, it's impractical to declare each as a unique variable, of course. Efficient method, okay, just array. Okay, really just talk about array. Placeholder for ship object, for a timer, it doesn't specify, and for the text, so what to display. Okay. The last 4 declaration does not begin with any value or type. It's perfectly valid to make this forward declaration, sometimes to, referred to as an up value. Well, if you do JavaScript long enough, I would pretty much say that is typically a bad idea, but oh well. Effectively, you're telling Lua about a variable existence. And even if we don't intend to use it later. Great. Displaying using display group. In previous chapter, we simply place object on the stage. This is essentially a core layer group which all display objects exist. In this game, we insert objects to distinct display groups for more controlled layering and organization. Basically, display group is a special kind of display object which can contain other display object and even other display group. Just okay, container. Blank sheet of paper which you draw image. All right, simple enough. So create basically 3 layer. All right. So 3 display layers, 3 display groups, and the way they call it. The most important aspect is the all these 3 lines. So because it implicitly will increment the layer, just like the when you're creating object. All right, loading background. So simple enough, just copy it over. It's simple. Should appear straightforward at this point. One very important difference was it is this back group. Okay, so put that in that group. Okay, yeah, so essentially seems like Lua have a type system to understand that this return a type of display group, and then in the function it will able to match it. If not, it will match order based on the type of the value. Or the one interesting thing is it also able to do implicit conversion. Right, like when let me reopen this, because over here when we do the tab count, the tab count is supposed to be what expect here is a text, right? But it have a double asterisk over there, so it did a conversion essentially over here. So it tried to, my guess is try to do a conversion if it works, and if it doesn't work, it should a string, something like that. Very interesting language choice, I would say. All right, first param is the group. This is the back group. Oh, okay. I'm doing this. So loading the shape. So okay, we create a shape over here. So this put in the main group, and the object sheets is this guy. This guy, or where is the object sheet? We haven't declared it before. Take reference to the sheet we load earlier. Huh? When did we load it? Oh, here. Completely missed it. So we typed it in but didn't declare it. Okay, object sheets over here. So this pass in a object sheet instead of a image, the file name of an image. Okay. So let's actually take a look at the documentation. The good thing is have a lot of documentation on this. So this is a file name. Group object parent. It didn't say it accept would accept image sheet in terms of based on the documentation. So here an overload. There you go. This is an overload. Okay, so then this is a frame index, width and height. While this one has this base directory, frame and height, width and height. All right, so index 4, which is the shape, which is this guy, 1, 2, 3, 4 shape. Okay. All right, it really doesn't make sense to me to separate that the decoration and the assignment. Yeah, to be honest, I would use this value instead of repeating it over here. That's a bad practice. But anyway. So let's continue, put in some more information to set the X and Y, content height, okay, the initial location, and tell the physics to add the shape with as a circle with radius is sensor. What is sensor mean? That's my name. That's okay. We don't worry about that. And in addition, we specified an important property is sensor equals to true. This specifies that the object should be a sensor object. So back here, this describe it is the body type, while here we didn't define a body type. Right, the body type can be static, dynamic, and kinetic. And then the params as optional. Did it talk about what can be put in the outline body? Nope, it doesn't seem like it. So somehow we have to remember those. Yeah. Okay. Essentially, sensor objects detect collision with other physical objects, but they do not produce a physical response. Oh, okay. So it won't bounce away because of someone hits you, right? If a normal body collides with a sensor object, the two bodies will not bounce off each other or cause any other physical reaction. This is ideal for a shaped object because we only want it to detect collision with asteroids, not bounce them off. Lastly, we give it a name, will be used later. So at this point, it feels like, okay, this is showing up fine. How about ABC equals to XYZ? It should work. Yeah. So Lua seems like being a scripting language. It allows you to put in anything, any properties in the object, just like JavaScript. Right, it's just the X and Y have special meanings to the engine, and but not others. Okay. All right. This property will be used later to determine what types of collision are happening in the game. Okay. Although the ship image clearly isn't circular, we add a circular physics body. For this game, we just being somewhat lazy by using this approximate body shape. Once you get more comfortable with Solar2D, you will learn how to add a perfect shape-based physics body to the shape which accurately match the image outline. All right. So set up the live tags and score. And just being lazy. so that we can quickly finish up the language, well, this learning part, so that I can start writing some real stuff. So let's check the result of our code so far, and okay, set new text UI group, that's fine. Lives live. To keep things simple, we use a special Lua method with the label to show our lives and score. Placing two periods together in Lua is called concatenation. Okay, add them together. Concatenating two string into one. All right. I missed template string. That's all I can say. So we should see. Oh, we have not displayed them. While we set the text. Okay, there you go. It show up. All right. Status bar. Okay, on mobile device. Usually display blah blah blah. Hide the display bar. Okay, display bar gone. Finally, let's write a function to update the text. Okay. So, well, okay. Again, just copy and paste. Now that we have basic, all right. Chapter 3. Let's go straight to it. All right. This we relatively simple. Creation eventually handled by function. So let's create a function, and that's fine. And we will generate new asteroid. So doing that on the main group, and then get object sheet, get the first one. Okay, fine. Always the first. Well, it doesn't really matter. It just rotate. It's always start at the same. That's fine. Since there will be a lot of asteroid, we need to keep track of them. As you recall, we initialize the table. We have asteroid table. Oh, here, this one, asteroids table. Okay. Yeah, I look forward to when I'm able to reference things in different files and stuff, and then I can clean this up a little bit. Okay, so we can insert. Oh, it's use the syntax is like this. So table.insert. So kind of like functional programming. Although why this is a dot? So table is an instance. It's a property, not a function. Why is that? Okay, model. To insert the new asteroid instant into the table, we can utilize the built-in table.insert. Shouldn't need a colon. Okay. With the, but this is built in. With the asteroid image now loaded and placed into the table, we can add it to the physics engine. Okay, so we're adding that. So add the new asteroid as a dynamic, and oh yeah, we want it to be dynamic because likely asteroid will bounce off each other. Okay, so as with the shape object in the previous chapter, we're taking shortcut. Okay, yes, understand. Finally, let's assign the asteroid my name, asteroid. So, lazy again, just copy and paste. All right, so placement. Now that's where the the random generator comes in, where from equals to math.random free. Okay. So either 1, 2, or 3. All right. So the random function can be m to n. I say m to n. Right. 3 is just 1, 2, 3. If then, is there a switch statement? Okay, let's start with that from the left. See, from the left, and then that's it. Since from the left hand side, they set the property to -60 because this is 40. Make sure it is off the screen. Okay, and then for y, we randomly place up and down between a value of 1 to 5. 500, right? It's 500 is the middle of the screen because our height is 1024. So 500 is about in the middle, so in the first top half of the screen. Okay, now that we have the starting point, we need to, well, for this, after all, we don't want any asteroids coming from a place that make it impossible to shoot them. No, if I'm writing a game, I'm definitely creating that. Okay, movement. Now that we have the starting point, we need to tell the asteroid where it should move to. This time we are going to use another physics command, set linear velocity. The previous command that we learned is apply linear impulse. Is that right, physics? Apply linear, no. This is, oh yeah, it is. Apply linear impulse. Yeah. Still need to figure out about how Lua language works. But over here is the same thing. It's calling on the object itself. All right. The new asteroid created this. Let me actually do some experiment. So like this. If I comment this out, it's still, well, will still work. Well, I have to try it later on. How about physics add body? How about I do? Yep, it does work. It's drifting away. And if I remove this, it crash. All right. So it does seems like the physics.add body is actually doing a mix in. It's adding adding functions to the shape object, right? It's adding some trace or instance level functions. right? It's either, of course, right now I don't know if it is a mix into the instance itself. Well, it's probably is an instance itself because it's there's no class, no anything like that, right? Because over here the shape is an image rectangle, right? So it doesn't make sense to get this to the quote unquote parent class. I don't know if that exists to the actual class. So this is adding the function, adding these kind of functionalities onto that object itself, right? So that's how this works. So let's switch this back. And make sure that it works again. Okay, that's fine. So might look uncomplicated. Well, no, not really. This is just random. Yep, every time is different. Right. Man, again, this is, well, really just for example. This is an example, right? It's not a good thing to hard code all this in there. Right, this might not complicated, but blah blah blah, moving slightly. Is a random to randomize it with 2 params. Okay, of course we understand that it's a range. So if we decide to call and run this now, we might see the Android slowly moving across. That's it. We haven't seen anything because this create asteroid have not been called yet. So did I miss where it is being called? Oh, create asteroid. Yeah, it's not being called. Yeah, it's not being called. So why it say it would display? Anyway, we will continue this by again more copy and paste. Rotation. So this get the new asteroid to apply torque random. Let's write it up to make it slowly rotate about the central point. We can apply the random amount of torque, so plus and minus. So it's spin left or spin right. That's fine. All right. So now firing mechanics. Skin of ship firing is similar to loading asteroids, but this time we will use a convenient and powerful method to move them known as a transition. Essentially, a transition is an animation method which allows you to change the state of an object across a defined amount of time. This can increase the position, scale, rotation, opacity, and more. You can even perform multiple transition effects on one line and specify an easing algorithm to make the transition run with non-linear interruption. We'll discuss transition more, but less. Enough talking and just put it in. Enough talking and just copy and paste. So let's take a look. Create an object, get the 5th one, which is the laser, and then say it is a dynamic. It will impact, but its sensor is true. Oh, because it will affect the other item, the other object. Makes sense. It's bullet. This is probably just a custom properties and put in name. treat as a bullet. The thing is, we really don't know what is expected by the engine, what is not. This make the object subject to continued collision detection rather subject to continuous collision detection rather than periodic collision detection at well-timed steps. Because our laser will be moving very quickly across the screen. This will help ensure it doesn't pass through. Okay, so this is a specific property expected by Solar2D. All right. So finally, I assign the value, assign the name. That's fine. Placement. Yeah, start from the ship location. Okay. This will correctly position, but there's one further issue to resolve because this function creates new laser after the shape, correct? So to back, so just layering, get it to the back. And to understand, right? So over here, this is also the main, right? So when we create different display group, we need to think about this ordering. I don't know if this just go one step, you know, the C order go -1 or not, but yeah, that would affect how things overlap with each other when the display getting a little bit more complex, right? Oh, so this sent to the very back of the group. Okay, but it's not necessarily of its own display, but not necessarily the very back of the entire parent stage group. Okay, in front of the back group, yes, of course, right, as expected. As mentioned earlier, we will move the laser up the screen using a transition. So, all right. So this transition to send the new laser, so Y to -40 every half a second, or what does it mean? Half a second. The first parameter transition new laser include a table which contains value, which this is the vertical destination. Within half a second, go off the screen. Okay, it go off the screen. It's -40. All right, not. So this is a world coordinate. Okay, so it's not the relative coordinate, it's the world coordinate. The screen, the content, the context, what is it called here? Content. Yeah, the display is the display reference, right? It's a -40 on that. All right, we almost, well, halfway through. As you can see, the person, you do that. So clean up, great. New laser are now correctly appear at the same location as the shape. Move upward. It's just one last thing, very important. Clean up in any app is crucial. Remove object programming when they are no longer needed, of course, out of memory. In Corona, well, Solar2D, there are various approaches toward clean up, and it will depend on the situation. For laser, we're going to use very convenient method known as on complete callback. Okay, so when the transition is done, okay, so this create a function, display remove. So because over here, this create a new, and here it create remove. All right. Doesn't have a name. Okay, anonymous function. Well, anonymous function, pretty simple. Tab listener. All right. So finally, it will start working. There you go. There you go. Okay, cool. So what time is it? So it's about an hour. So let's stop here. Let's take a break. And then we'll take a break for 5 minutes and we'll be right back. All right, so let's get back to it. All right, so now let's work on this moving the ship. So as this show, just create this function. Event target, okay. And notice that unlike our previous function, actually it accepts an event. All right, so yeah, Corona largely event-based framework. Okay, that's fine. Specifically for this routine or function, the event param, which is a table, tells us what object the user is touching and dragging. the location of the touch in content space. Okay, so the whole content space. And a few other pieces of information. You will see this event parameter used frequently as you move forward and study existing code samples. So it's a good idea to be familiar with it now. Okay, that's fine. Inside the function, to make things a little clearer, let's set a local variable shape equals to event target. Because we're expecting we're touching the shape. Well, or passing that object back, seems like it. And the target is object which touch or tap, so setting this local variable as a reference to the shape object will save us some typing as we work through the function. Okay, so the touch events distinct from tap event have 4 distinct phases. So begin, move, end, and cancel. Okay, initial touch, begin is initial touch on the screen. Move indicate that we move, and end is lift. And when the system cancel tracking of the touch, so maybe some system it pop up a notification that caused it to cancel. Let's locally set 4 distinct phases. Set the phase of the touch event. Okay, so just pull it out as a local variable. Okay, so with this phase locally set, we can use if then. Okay, if the phase, how do I know this? Although how do I know this is a touch event though? Or maybe when it listen to the touch and send it over. That's why this is called a drag. So display current stage, set focus to ship. Okay, fine, pretty simple. And then initial offset. Let's take a look at that. Touch offset. Let's store the beginning offset position of that relative to the ship. Okay, event ship X, and okay, the ship is at location X, and then we are touching, so like this, right? Depends on where we are touching it. So the event X, say for example here, is on the left hand side of the center, because the ship's XY is at the center of the ship. Okay, so get that. So if we move, but look careful, that's where our offset come into play. If we ignore the offset, it would jack, it will jump the object, right? Correct. Yep. So touch may not be exactly at the center. Fortunately, factoring the offset value will produce a smooth, consistent dragging. All right, makes sense. Right. So x equals to x. If x when it moves is event x, the new location minus the touch offset. So let's make sure that we understand this. So the event x is in the world coordinate of x. Say for example, the whole screen is like this big, and we are touching here while the ship center is here. Now, so the offset is this minus that. So it will be, say this is a bigger number in this example. So this minus that will be a negative number. So that's the offset to the left. So once when we move And since our finger is over here now, say we move it over here, we need to minus the minus to add it back here, right? To the same place, get back to the center of the ship X. Okay, so for this game, the ship movement will restrict to just left and right. Oh, okay, along the x-axis. Can do that for the y as well. So, but we're not going to do that. The final condition case include both the AND and cancel phase. AND in it release, and cancel indicates the system cancel temporary touch. Both of these cases handle the same conditional. For this game, we simply release the touch. All right, makes sense. Again, copy and paste. So set focus to null. So null is Lunar's null value. So it removed the focus. All right. This logic has a problem though. How do I simulate a oh, we haven't called it yet. Oh, damn it. Let's complete the touch handler with one more command, return true. Okay, so return true. So yeah, let's also copy it over here, right? Basically saying the event is being handled. Okay, so this completes it. Is now we can drag, right? See, there's a problem here. The logic is not complete, right? So if I touch the very right hand side of the ship, I can move my finger all the way to the end and the ship will be completely gone, right? And then the same thing will happen over here. The ship will completely gone, right? Wow. But this is just an example. So as the comment indicates, there's this short, all right, yeah, simple. So the touch listener, yes, we just add that. Game loop, many game including a game loop. Okay, so let's create a game loop. For this game, let's remove Android when they have drift off screen. And we declare this table as a place to store a reference of each asteroid. It may not have seemed relevant at the time, but it's now come into play. Look through the table. Okay, we just copy this part, whole thing. All right, so for 1 equals to okay, count in. So let's understand this. In this case, we need to count down or this syntax is the number of syntax, I guess. Let's see, we will need to count down starting from the number of asteroids in the asteroid table, but there's one slight catch. The amount will constantly change as new asteroids are created and others are destroyed by the paper. Fortunately, Lua has a convenient way to count the number of elements in the table, accomplished by simply prefacing the table with a pound. Okay. As you can see, we use the method for loop, which take the indicate form. Basically, Lua use index I, start at that stop at 1 and count -1. Okay, basic for loop essentially. If there are 10 asteroids, the loop will iterate 10 times. It's just one iterator one. Yeah. So this just get the I, and x is -100, or okay, out of bound. Basically, this is just saying out of bound. Then it will remove, display will remove, the table will remove, and wow. It's a bit messy over here, this logic, because as you know, as you might know, when you're doing a for loop, you're removing a one entry, and then it changed the number. Yeah, that would be normally would be a problem. That's why this is doing in decreasing order, right? So that when the entry is being removed, when you go to the next entry, it's still inbound, right? So say the very last one get out of bound, so you call that, and then you will remove it. So then you move to the next one, which is -1 is still the next item. Instead, if you're doing increment, if you're accessing the accessing the last element, and I don't know, would it work? Would it work? I don't know. It's always confusing, this kind of thing. So need to be careful about this. So let's examine these commands in more detail. For each iteration of the loop, we declare blah blah blah. This is simple enough. Simple enough. Okay. It's very important to understand basic Lua memory management and how it relates to Corona display object. The first command above, display remove this asteroid, will remove the asteroid from the screen visually. However, that command alone will not release the asteroid from Lua memory. Why? Because we store additional reference inside the table. Of course, it's a reference count system. The number of count is not 0. So once it's 0, it will, I don't know if it's garbage collection or it will just directly delete it. So it removed the external reference, no more reference, and then, it's garbage collection. So Lua has a garbage collection process. All right. So that concludes our cleanup. Basically, each iteration of game loop, we use it to check, and then the data are removed and done. So the loop timer, although you might imagine a game loop is code functionality on every frame up to 65 times per frame, that's not necessarily true for every app, because our game loop is a standard function. We have complete control over how often it runs and when. There are a couple different ways to run a game loop function repeatedly. In this game, we clearly don't want to generate 60 new asteroids per second. And it's not necessary to perform cleanup tasks that often either. So we will be implement repeating timer instead. So that's actually an interesting thing, right? Because the fact that the game loop putting these two together is a problem, because every time this function is called, you will create a new asteroid. And so the separate concern is broken, because you definitely want, well, when there are more asteroids, you want to call this more often than calling this. Maybe that's a random generator, something like that, you can put it over there. But in the new asteroid, and have another layer of logic over there to determine if the asteroid will be created or not, but that's some detail to be checked. But still, the overall logic, the game loop, doing everything on on the fixed interval is definitely right. I don't know if if there would be are we at the level of having different interval game loop in terms of memory management and all that, but well, this is a simple example, so yeah, just do that. Game loop timer, okay, again, so that's when we define it up here, so that's where we are setting it. Right, there you go, you can see it start coming in. Right, and then when you hit shoot, it doesn't do anything and it doesn't respond to it yet, but it's working. So perform with delay, so every half a second it called the loop, and what's the last 0? Finally introduce optional iteration. Okay, it will just fire once and stop. So basically this is specifying 0, make it a interval. If not, it's just a set timeout. Repeat for that number if later, but don't be fooled. In this case, we are not telling to run 0 time, but we repeat forever, right? 0 or -1. I would say -1 as default would be best. Probably there's some legacy code in place. So that's good. Collision handling now. How much time we have? It's almost 1.5. Well, we just have another 20 minutes, so let's keep going. So collision handling, the time to handle collision. When the laser hit the asteroid and when it collide. So collision are reported between pairs of objects. They can be detected either locally on an object using an object listener or globally using a runtime listener. Different games require different methods, but there's a general guideline. Local collision handling is best utilized as one-to-many. Okay, for example, one player object which might collide with multiple enemy powers up, etc. And global is better many to many. For example, multiple hero characters which may collide with multiple enemies. In this game, with just one player object and ship, it might seems the best choice to use local collision. However, the game will also need to detect collision between multiple lasers and multiple asteroids. So global collision handling is better. Can we mix it? So before we get into collision handling, we need a function that can be called to restore the ships following collision with an asteroid. In our game, we will mimic classic arcade games where, as the new ship fades into view, it's temporarily invincible. Okay, after all, it won't be fair to allow player to die consecutive times without giving a chance to dodge incoming asteroid. Okay, cool. So let's copy this. Just copy and paste, man. Just copy this. So we set a property is active equal to false, and the content center at the center, and then content height -100 to put in into initial location. Is that right? The ship. Where is the ship setup? Yes, yep, at the same location. Okay, at the same location. The phase in, do a transition. Transition the ship with alpha. It start from completely invisible. Completely invisible. Oh, completely invisible. Time 4000 on complete. Oh, default is 1. Yeah, 1 is visible. So it start as in invisible. Okay, on complete, I see. Okay, is body active. So this is, again, this is a Solar2D thing. With that, because the word body is specific to Solar2D, so mark that as not active and then active again over here. Transition, reposition. Okay, the final command does not make complete sense right now, but after we add the def function further on. All right, so let's continue on collision. So we get the two objects on collision when it begin collision. So this is a little bit different than. Okay, yes, it's the same. It's just get the event, and then the event for collision is it begins. So we get the two objects. Begin and end. Begin collision phase are most common you need to handle, but there are instances where detecting the end phase is important. Don't worry too much about this now. Here we simply isolate the begin phase by wrapping our functionality in a conditional clause. For simplicity throughout the functions, we reference to the object involved in object 1 and 2. All right, so laser and asteroid. So if the name, we use the name, right? We want to do this copy. Okay, if that or that, okay. When detecting collection with global network, there's no way to determine which is first and second. Okay, so that's why you need to check on both way. Inside the conditional clause. Oh, it seems like there was a small, very small earthquake. Inside the conditional clause, let's begin by simply removing the two objects. While a fancy explosion would be awesome, this project merely exhibits how to handle collision. Okay. Yeah. So the laser got laser and asteroid annihilate each other. So let's remove the destroyed asteroid from the asteroid table so that the game loop doesn't need. So we use another for loop to it. Oh man. Well, yeah, that's base. Oh, it's doing it like that. Okay. Yeah. I would definitely figure out which is laser and which is an asteroid and just check it once instead of keep checking it multiple times. But this is just an example, so that's okay. Utilize a minor efficiency trick. Yeah, break, fine. Just break the statement, simple. Finally, we want the player to destroying if we increase the score. Here. Okay. And update the text. Yeah. Now let's handle the second collision condition, asteroid and the ship. Yeah. Copy this. It's just too simple. All this logic. Right. So put this over here. Is that right? If yeah, we need to end that, and then else if then end this. Died. The die is a global variable. Oh, okay. If die is false, then it's set to true. Okay, that take care of when it was invincible at the same time. Okay. Come on. So when the life is 0, then it's just game over. By this is signaling the ship is gone. Else alpha is set to 0, and then it restores ship. So okay, that's pretty straightforward. It's not good programming in any way, but again, just example. All right, the default else clause, where the player has at least 1, we make the ship invisible by set alpha to 0. All right, this type to restore ship function and set it back to 1. All right, okay. Collision listener, let's add the collision listener. All right, seems like, yep. Seems like we're done. Let's hit some asteroid kill. Okay, so it was doing that. Die again, and then this is not ready, die again. Okay, life 0, game over. Oh, and the score is updated. All right, we are done. We are done with this project. Pretty simple. So how many lines of code? About 200 lines of code. And definitely some refactoring is needed, you know, to make this looks nice. Is have when we talk about design, you know, this mixing all the UI logic and the business logic together is horrible. But I won't do the. I was thinking about doing some refactoring as an exercise here, but think about it again. Maybe just keep going, going through all the examples, and then when I work on my actual game, then we will do that kind of refactoring. All right, so that's it for this stream, and hope you enjoyed it, and we'll see you on the next one.